We'll start discussion on vector and commercial calculus. Vector and commercial calculus. So this is the topic that we are thinking that we would start vector and commercial calculus. Someone can say that advanced vector or advanced algebra and calculus over a vector. Okay, so a vector, what is advanced vector? What is advanced vector? So advanced vector is a vector which is a vector field. A vector which is a vector field is called advanced vector. Simple, right? Vector, after all, if there is something, if there is a boat, if there is a boat that is afloat on a sea on a water, if you make very advanced, then you can attach engine to it. If you make very advanced, then you can make ship. If you can make it advanced, it will become a cargo ship. Okay, passenger ship, cargo ship. If you make it advanced, whatever you do, it will not fly. The ship is ship, boat is boat. So the vector is, some vector is energy which has a magnitude and which has a direction. Okay. Similarly, what is difference between numerical science and algebraic science? What is difference between numerical science and algebraic science? Numerical science is fixed, where algebraic science is a variable. Where, like, if numerical science talk about a number called 5, then there is algebraic science where variable called x. Now x can have many possible values. One of them is 5. Okay, something like that. So if I have a kind of a vector and which has a direction, then it is a static vector. 2i plus j. 2i plus j is a vector that is passing through the origin and through point 2 comma I. That is 2i plus j. That is a static vector. What is algebraic vector? xi plus yj, xi plus yj, or 2xi plus xj, 2xi plus xj. If that is the case, then when x equal to 1, then it becomes 2i plus j. This is what we were talking about in term of static vector. 2 2i plus j. But x can be infinite. In that term, this vector can be infinite. I mean, what is 2xi plus xj? 2xi plus xj. What is that? If you keep changing x value, then the vector will start changing, because vector has a direction and vector has a magnitude. Every point on xy plane, if I take xy plane, every point on xy plane, this vector is different. Like if I have a numerical value 5 and if I have algebraic variable x, with different x, the value is different. Like that, if I have a numerical vector 2i plus j, then I have algebraic vector called 2xi plus xj. When x equal to 1, then it is exactly equal to 2i plus j. But if I keep changing value of x, then this vector is changing. What I mean is, if I if I take xy plane, if I take xy plane, or simply I take x-axis, just x-axis, along the x-axis at every point on the x-axis, this vector is different. If x equal to 0, then this vector is 0. When x equal to 1, okay, this is x-axis, this is origin. Now when x equal to 1, this vector is along this direction, 2i plus j. Okay, when x is 2, then it is 4i plus 2j. Again vector is in same direction. This proves that vector, it is in same direction. But what I meant was vector direction would change when x is changing. Okay, if that is the case, consider it xi plus yj. Okay, it is xi plus yj. That is the vector. Now, if it is xi plus yj, xi plus yj, if that is the case, then along x-axis, vector is exactly along x-axis, xi. Along y-axis, vector is exactly along y-axis. If it is 4, comma 1, then vector is 4i plus j. Everywhere vector direction is changing. So here vector direction is along this direction. On y-axis, vector direction is along this direction. And any point, so every point on xy plane, this vector has different magnitude, different direction. This is called algebraic vector. So algebraic vector is considered as the most dynamic vector. It's a collection of so many numerical vectors. They come together and in algebra in a generic form. Algebra means in a generic form because we are considering the variable. When we are coming to a level of variable, then it is a generic term. Okay, so algebraic vector. Now we are kind of in a case, consider there is a force vector. Okay, we are too much into energy calculation. Energy, why energy? Energy, why energy? Energy cannot be destroyed. If you have energy, if you gain energy, then energy cannot be destroyed. Energy changes its form. Energy is considered as one of the most perpetual entity in calculation. Okay, like if I am running with this velocity and then I am touching another, I have a mass, I have a mass, and mass is running with a velocity. Now it is colliding with another mass at angle of 45 degrees. If there is a mass and it is going like this, then if there is a mass, another mass, that is a vertical line is there. There is a mass that is a cube. If it is a cube, then there is a vertical line. Now there is a vertical line and energy, another mass, consider this is a sphere and it is going and hitting in on the cube. Okay, now it is going with 45 degree and hitting the cube. Okay, it is with mass m and velocity v. If it is going with different angle and hitting the cube, which is of this dimension and this much mass, then how much cube would be displaced along this direction? Now try thinking about velocity, this velocity, that velocity, and then this. And then, okay, let's try with the force. Then this force and that force, and then mass into, let's try with acceleration. Let's try with the momentum. Let's try with the power. Okay, you will keep roaming only. Energy cannot, if this ball has energy that is going to hit, energy cannot be destroyed. If this ball is going and hitting that, after hitting it, okay, consider this ball, just drop it, means it lost its energy completely, means it transferred full energy into this cube. If this cube is now gained that much energy, then what, and mass is there, what would be the velocity? mv square or mv square or half mv square equal to whatever the energy this ball was carrying. Mass we know, then how much velocity it will gain. Rather than applying Newton's first formula and second formula and third formula and Darwin and this and that, not required. If you go with energy calculation, then your life is life is solved. That much only. Einstein is a scientist. He is considered as the, I cannot say he is a scientist. He is much bigger than me. So Einstein, Sir Einstein, is considered is the pioneer in energy calculation. He was the most vocal in the calculation of energy in mathematics. Rather than going through first law, second law, third law, fourth law, here and there, Einstein said concentrate on energy. Energy cannot be destroyed. If you focus on energy, then many calculations would be easy. This is what he was saying. Energy equal to mc square. This is what he, mc square, mass into velocity square. If a mass traveling with a velocity c, then it is carrying energy of mc square. E equal to energy equal to mc square. If I have energy, if I have energy, okay, I have some 1000 joule of energy. This is what I'm thinking. Okay, and then I threw a ball, and after that I fell down. I completely transferred my 1000 joule of energy in the ball. Okay, the moment ball leaves my hand, at that time, what is the velocity of the ball? mv mc square equal to 1000 joule. M I know, then square root, that much velocity ball is carrying, but it is leaving my hand with that much energy. After that, Earth gravitational pull comes into the picture, then media comes into the picture, that is air. So there it will lose energy, whatever it is. But when it leaves my hand, so energy is the thing that someone need to catch it. Okay, anyway, now we are doing computation over the kind of a force field. So if I have a force field, okay, this is what example I keep on giving. So if I have a force field, then force field has has component as per the vector fundamental. Force field has a component F1, F2. F1 is a component of force field along I vector x-axis. F2 is a component of force field along J vector, that is y-axis. F equal to force field equal to F1i plus F2j. What we have seen is that if dF2 dF1 by dy, okay, this is F1. F1 is a force that is going along y-axis. If this F1 is changing as we go along y direction, this is y-axis, this is z x-axis. If this force is changing as we go along y direction, then there is dF1 by dy. If there is F2 that is going along y-axis, and if it is changing, if I move along x-axis, then there is dF2 by dx. Okay, if there is a kind of okay, consider that I am trying to calculate line integral energy. Energy is force into displacement. Energy is force into displacement. So if I'm trying to calculate, like there is a mass, there is a bolt, not a bolt, there is a bolt that is along this circle. There is a bolt that is along this circle, and bolt is rotating like this. If I give energy to the bolt, bolt would rotate inside the circle like this. Okay, if that is the case, and there is a force vector like this, because of the force, this bolt is rotating like this. This is x-axis, this is y-axis. I mean, this circle is lying on the xy plane, on the earth only. To facilitate to make the presentation, I rotated it like this. So there is no earth gravity comes into the picture, because earth gravity is orthogonal to this plane on which this is lying. So in that case, this is x-axis, this is y-axis, this is z-axis. Now I rotated it. This is x-axis, this is y-axis. Now bolt is moving from here to here because of this force. If it is moving from here to here, if it is moving from here to here, consider there is a one infinitesimally small length I take on the arc, very small. If I take very small length on the arc, then that will be similar to tangent at that point, one small tangential line at that point. That is a curved line. This curved line from point A to point B will be considered as, so consider, now I am magnifying it. Now consider this point to this point, this bolt is moving. Then this is the arc on which bolt is moving. If this is the arc on which bolt is moving, now I cut it into 1000 points. So small section I cut it. Now there is a very small section like this. It is so small that the beginning point and end point, I consider it as a straight line only. If this is the straight line beginning point and end point, now this I can consider as one point from here to here, and another point horizontal. One is vertical, one is horizontal. Horizontal end is point B, alpha, I say alpha, and then begin point is A comma B to alpha comma beta, and this is M comma N. Actually, it is going in arc fashion. From A comma B to alpha comma beta, the line is going in arc fashion. I cut it so small that it behaves like a tangent straight line. If that is the case, then this is A comma B alpha comma beta. From vertical, this is M comma N, and horizontal from M comma N, this is alpha comma beta. Or someone can say, If it is A comma B, then if I go vertical, then it will remain as A only. Then A comma B, then A comma beta. A comma beta. Okay, I'm sorry. Here x is same. Okay, so this is A comma B. If I go up, then this is A comma beta. From here to here, if I go, x is changing. Now it is alpha comma beta. Okay, if this is the case, then if force vector, force, this is the F1, there is a force vector F for which there are two orthogonal components. One is F1 and one is F2. Capital F force vector equal to F1I plus F2J. Okay, if that is the case, then if F1 is changing along y-axis, there is a dF1 by dx. If that is the case, then it will produce a torque on this line, because F1, if dF1 by dx is 0, it is not changing, then it will push through. Everywhere force is same, it will push through. If here force is different, here force is something, and here force is different, it will make a torque. Similarly, there is another line like this, that is going from this point to this point. There is F2 in this direction. Here F2 is there and F2 is changing everywhere. It will make a torque. If these two torque, this torque and this torque, if they cancel each other, then there won't be any torque. If there won't be any torque, then from point A comma B to alpha comma beta, okay, the line integral, force into displacement, what we are doing, it is path independent. This is what we are saying, because every moment on the line, they are cancelling each other, df2 by dy and df1 by dy and df2 by dx. So line integral is nothing but from a comma b to alpha comma beta, force into displacement, force vector dot the position vector A to B. I mean, it is path independent. Path independent, if it is, then what is the scenario that we can get? Path independent means work done. Very like we have given example of the earth. If there is earth is pulling, or there is a gravitational force which is pulling any item from here to here. One item is moving from here to here. Earth is losing energy because earth is working. Because of earth power only, item is moving from here to here. If you go in a space where earth gravitational pull is negligible, I cannot say zero. People say when you go 100 kilometers, earth gravitational pull is zero. It is not zero. But okay, it is tends to zero only. If that is the case, if you keep any item in a space like this, it will be still there. That's why it is space. Means there is no gravitational pull that is working out there. Then how you bring item from here to here in the space? From your hand, you have to catch the item and pull it here. Means you are losing the energy. External person will say, oh, item moved from this location to this location. This means there is a work done. Work done is synonym to energy. Energy came from your body and item moved from here to here. Similarly, if item is moving under earth gravitational pull from here to here automatically, right? If I just leave it here, it comes here automatically. So it disproves that someone is working, right? That's why there is a movement. Earth is working. If earth is working, earth is losing energy. How much energy it is losing? It force into displacement. Force into displacement. If it is path independent, then the energy the earth is losing, it is only dependent upon begin point and end point, not on the path. If it is a straight line, then I can just say force into the length of the line. That much is the work done. If it is, this is the beginning and this is the end and bolt is going like this, then what is the energy earth has lost when begin point and end point is? If it is path independent, then earth is losing same energy, because it does not depend upon the path, it depends upon the begin point and end point only. Okay, we have seen many things in the path independent. When you say something is path independent, we say it is path independent. There are many fundamentals into it. If I calculate this is point A and this is point B, there is a force field from somewhere. An item is moving from here to here because of the force field. It can be magnetic force also. Magnet is kept somewhere, and because of magnetic pull, a bolt is moving from here to here. How much work done bolt is doing? Now, if I make this bolt move from here to here, it is moving because of the magnetic field. Okay, now from my hand, now I push this bolt from here to here. How much is the work done? If work done is zero, okay, whatever is the work done from here to here and whatever is the work done from here back to here, if other is I consider negative because of the vector direction, then net energy or net work done is zero. If it is zero, then it is path independent. Path independent means if begin point and end point are same, like it is going from here to here and here to here, or in a circular fashion, this bolt is going from here to here, and then it is coming back here to here. Means from here to here only. If from A to A, there is a computation for energy, that is force vector dot d of position vector, and that is zero, then it is considered as path independent. Okay, whatever it is case. So we have given many way to calculate it is path independent. One of the way is that this the line integral or the energy calculation or force into displacement vector or force vector dot d of position vector, if from A to A or in a closed loop from begin point to begin point, if it is zero, then it is path independent. Or if df1 by dy equal to df2 by dx, then again it is path independent. Or f1 dx, what is the energy calculation? Force vector dot d of position vector. D of position, if I take any point on the path xy from origin, if I calculate a position vector, that is xi plus yj, then energy calculation is force vector dot d of position vector. Force is f1i plus f2j d of xi plus yj, f1 dx plus f2 dy. If this integration resolves into algebraic function called small g, and if, for God's sake, dg by dx is f1 and dg by dy is f2, then again means the net integration what we are getting g is only depend upon f1 and f2, because dg by dx is f1, dg by dy is f2. It is not always the case, but whatever it is, this is how it is. So if it is like that, then it is path independent. Okay, because the net integral energy calculation, that is G, is only dependent upon F1 and F2 and limit A and B, begin point and end point and force vector field, not on the path independent. This is, I always say, this is one of the most powerful invention made by mathematics, and based upon this invention only we see satellite that is rotating around the earth, because people know very well that satellite will get attracted from the earth only, and then earth start pushing energy on the satellite. This is what people don't want, because if earth energy is involved in the satellite movement, then there is a big problem in the satellite. So what direction it should move, that earth should not impart any energy on the satellite. If that is the case, then earth will not put any hindrance on the satellite movement, because people know that earth's gravitational pull is path independent. We have proved it. Please watch our video, that is vector algebra and calculus. There we have proved that earth gravitational pull is path independent. This much people know now. Okay, now, like, so how I can check that my vector field is path independent? Just see df1 by dy and df2 by dx. If they are equal, then it is path independent. If they are equal, then this is path independent. Consider there is a force vector field called 2xy, 2xy I, 2xyi plus xyj. There is a force vector field called 2xyi plus xyj. This is an algebraic vector or vector field. df1 by dy, 2xy df1 by dy, it becomes 2x. df2 by dx, it becomes y. 2x and y are not equal. If that is the case, then this is not path independent. If this is not path independent, under a force vector, that is 2xyi plus xyj, if you, that is a magnetic field vector, consider, and then magnetic field vector is a path independent, but whatever it is. I have some new magnet I have invented, and its vector field is 2xi plus xyj. If I keep a bolt here on a line, and bolt is going from here to here because the vector field, and then I'm pulling it from here to here back, so one energy is imparted by the magnet, another from my body. They should be opposite to each other. If this energy calculation from here to here and here to here back is from A to A only, if it is not zero, then this is not path independent. And it is not zero because force vector field df1 by dy and df2 by dx are not same. This is called curl calculation also. Curl means torque. Curl means what is the tendency of force vector field to rotate something. Okay, like if this is if I talk about a two line. Okay, if I talk about two lines are they are attached like this, and there is a force field that is 2xi plus xyj. Under this force field, okay, under this force field, if this line integral, if I calculate, then this force field, this line is receiving the x component of the force field because this is vertical. That is 2xy, where df1 by dy is 2x, means this force field is changing if I go along y axis. df2 by dy on this line f2, that is the vertical force that will apply. df2 by dx, it is changing, but they are not neutralizing each other. If that is the case, then this guy would be creating more torque than this guy. In that case, it will rotate like this or it will rotate like this. Okay, if this guy is creating more torque on, like, in comparison to this, again it will rotate like this. So if there is a torque, if we see there is a torque that is seen on any item, then there is a curling. Curling means rotation. It will rotate. This comes in commercial calculus in the sense, like there is a river. There is a river, and river, typically if you enter into the river, if someone enters into the river, and then at the beginning water is shallow and there is more or less there is no current there. Current will be in the center only of the river. If someone go there, then river starts pushing it, that is all right. If river is starting pushing it, that is all right. He can more or less he can swim. But consider when he go to center, there is a whirlpool. There was no whirlpool. That's why he went in the center. He was swimming and he went in the middle of the river. Suddenly whirlpool started. Now he is also a kind of astonished. How come whirlpool started? Because river is flowing like this. Now consider this is a big river, and at the center water is like this. Now this person entered the river at the middle. At the middle, this is the force. One side of the this is the river. This is the river that is flowing like this. If river is flowing like this is the middle portion of the river. Middle of the portion of the river, current is high. Now the person is swimming, knowing that when he reaches the middle, he will be thrown away by the river. But slowly, he can cross the middle current. But when he comes here, suddenly he starts rotating. Okay, this person who is coming here, suddenly he starts rotating. Suddenly, all of a sudden, there is a whirlpool because of the person only. And then, okay, so now it was very difficult for him to break the whirlpool, or some helicopter came and some other guy, they somehow he saved him. But he is surprised, he is astonished, because how come there is a whirlpool? Because if I consider the two end of the middle current, here here if this is considered as the f1 f1i, then df1 by dy is there. The force field is changing here along the y-axis. Along the y-axis, the F1 component, the x-axis component of the force in the river is changing along the y. dF1 by dy is there. What about this force? There is no this force. River is exactly moving in this direction. If that is the case, if there is any line here, then it will make a torque here. And person started rotating. Now he is thinking, when he somehow got sick, he got saved. When he came on the bank of the river, now he is thinking, I saw there was no whirlpool out there. There was no swirling of the water. Water was not rotating. How come it started rotating automatically? Because that is the nature of water there. Because that is the nature of the water there. Now, there would be a magnitude of the curl, that is dF2 by, okay, the how much energy that curl is making, and those things that we will see. That's why it comes under commercial calculus. Or your rocket is going somewhere, and there, because of some wind or something, your rocket is started swirling. Aeroplane started swirling. This comes under commercial calculus, because you have to consider this. If you are making a resort and there the river is flowing, and you are saying that my resort per day or per night or per 24 hours charging this, because there is a river and you will enjoy your life, and somehow someone enters and he really enjoyed his life, because there's no commercialization. He never thought that. So he can put a mathematics now. If you can tolerate this much curling, then you can enter. Okay? Or the curling factor in the river, at he can put a board. At along the river, if you move 5 meters, then curling factor is this. Curling factor is this. If you go at the center, the curling factor is this. This curl energy is this much. Now think how much is your energy, and then you can tackle the curl. Okay, that much only you enter. Now business is more, right? Because now people understand what are the caveat out there. Okay, rather than going to any name resort where they don't know anything, only they are there to earn money. So this is commercial calculus anyway. So df2 df1 by dx, or df2 by dx minus df1 by dx, it is called curl factor. Okay, so curl factor for the path independent. Curl factor for the path independent. If I take a closed loop from here back to here, if I take complete curl factor in a closed loop, that is df2 by dx minus df1 by dy. If I take in a closed loop, then this in a closed loop, then I'm sorry, there is no loop here, right? df2 by dx minus df1 by dy. It talks about the curl factor. So if df2 by dx minus df1 by dy equal to 0, then curl factor, rotation factor is 0. If it is not 0, if it is not 0, then if it is not there, if it is 0, then vector field is path independent. If it is path independent, then work done to move any item under a force field, a vector field, from here coming back to the same location is 0. If df2 by dx minus df1 by dy is not 0, then there is a work done that will be coming from here back to here. Okay, what is the work done? If df2 by dx minus df1 by dy is not 0, then from A to A, if I compute the work done is f1 dx plus f2 dy, if you remember, f1 dx plus f2 dy from A to A. That is the work done from A to A, or A to B plus B to A. Okay, so or A to B minus B to A, whatever it is. But it is not 0, it will not be 0, because force vector field is not path independent. What is the work done? There is one Mr. Green come into the picture. Okay, now Mr. Green is saying that if df2 by dx minus df1 by dy, if this is the sign of path independence, Okay, if this is the sign of path independence and in a closed loop for path independent means df2 by dx minus df1 by dy is 0 if it is path independent. And then other is in a closed loop. If I calculate the work done, that is f1 dx plus f2 dy from a to a, again it is 0 if it is path independent. He is saying looks like the energy calculation and df2 by dx minus df1 by dy has some relationship because both are 0 when it is path independent. If it is not independent, then df2 by dx minus df1 by dy dx dy along dx dy along the surface area. Underneath, we are calculating the closed loop integral is the work done. This is what Mr. Green is saying. This is opening a new arena in the surface area calculation. Mr. Green had distinguished brain. That is for guaranteed. Okay. So he is saying, consider I am calculating work done from point A back to point A. From point A back to point A. Then it is a closed loop. If it is a closed loop, then it has a surface area. In this surface area, if force field capital F is continuous, it has no hole here, or df2 by dx and df1 by dy, this differential exists in the surface area. It is not infinite somewhere. If that is the case, then df2 by dx minus df1 by dy integration over this surface area dx dy means integration over xy plane, dx dy means integration over xy plane. Okay, if I integrate it over xy plane, I get the work done by any entity that is moving in a line that is the peripheral of the surface area in a closed loop. If I can calculate the surface area integral df1 by df2 by dx, df2 by dx is a vector. df1 by dx is a vector. df2 by dx is a vector. f2 I'm sorry, df2 by dx. Okay, df2 by df2 by dx minus df1 by dy. It doesn't look like a vector. F2 is a algebraic component of a vector. df2 by dx is algebra. df1 by dy is algebra. Algebra dx dy. Then whatever comes, if I integrate over this surface means minus x to plus x minus y to plus y. If I integrate over this surface, it is same as work done, that is from point A to A in a, if I take the peripheral or perimeter of this closed loop. Same thing. Or from point A to A, f1 dx plus f2 dy is same as minus x to plus x minus y to plus y. That is the surface area region. df2 by dx minus df1 by dy dx dy. Integration over xy plane of the df2 by dx minus df1 by dy, because you know it is not path independent. If it is path independent, then df2 by dx minus df1 by dy is 0. Then anyway work done is 0. But if it is not 0, then this is the work done. This is what he is saying. Integration over this surface. If I consider this as xy plane, now we are entering into 3D because of Mr. Green's. So Mr. Green, as per the 3D, if this is xy plane, this is xy plane, this is full xy plane. Okay, if this is full xy plane, then integration of df2 by dx minus df1 by dy, that will come as x and y. Consider that is z. That is another function gxy or fxy. That is the z. Z value integration over xy plane dx dy. Limit is the circular region, because I am taking, actually I was trying to take one circular path only. But path, since it is a closed one, it made a surface, circular surface, complete, consider as a disk. Now it is a disk that is lying on xy plane. If I calculate the df1, df2 by dx minus df1 by dy, integration over dx dy means integration over xy plane, where the limit region, no, it is a region, limit region is this circular region. Then we calculate the same work done along the perimeter, along the line of along the perimeter of the circular region from point A to B. This is what Mr. Green is saying, but it is opening a door of 3D. If it is opening a door of 3D, then dx dy, otherwise it was f1 dx plus f2 dy integration over lower limit to higher limit. Here it is a to a. That was the work done. But if we be saying df2 by dx minus df1 by dy dx dy, if it is dx dy, then I am free to enter into other coordinate system like polar coordinate system. Consider that f force vector is 2xi plus xyj, 2xyi vector plus xyj. If that is the force vector, then df2 by dx is y, df1 by dy is 2x, y minus 2x, y minus 2x dx dy. That is the integration. Now it is easy, right? Y minus 2x. Okay, if I integrate with dx first, it will become 2yx minus x square by 2. Okay, whatever is the x limit in the circular region, that I have to provide minus a to a. Whatever it comes now, it will come in term of, oh sorry, if it is a circular region, then x is minus a. If there is a circle on the xy plane, x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square. So first we'll integrate with the y1, y first, then it becomes y square minus 2xy. Then y square I can put as a square minus x square by 2 minus x into a square root of a square minus x square dx. Hope. Very difficult, very difficult. Okay. A square minus x square by 2 minus x into a square root of a square minus x square dx. I am not able to do it. It is very difficult. Okay. Okay, let's try going into polar coordinate system. Okay, if it is x dx dy, consider x as r cos theta and y is r sin theta. As per Jacobian, dx dy will become r d theta dr. Now here y is r sin theta minus 2x is 2r cos theta. Okay, now r will come out and r is there, r square. Integration of r square is r to the power 3 by 3. Then a to the power 3 by 3, radius is 0 to a to the power 3 by 3, I can keep outside. Now here, now it is only in terms of sine theta and cos theta. Where theta, now you can integrate easily, theta is 0 to 2 pi. So quick, right? If I go through this work done through line integral, then it is x dx plus y dy. X is x dx, y is a square root of a square, okay, square root of a square minus y square and then dy. It may be difficult, or if I try with another difficult example, certainly it will be difficult. Or then if I put limit, then if somehow if I manage it, the limit, if I go, then it will be difficult. So it is easy now. If I go with the Mr. Green's way, it is far easy because we can change the coordinate now. From Cartesian coordinate, we can jump into spherical other coordinate system. So that is much easy. Anyway, this is not my invention. Mr. Green's did this invention that if it is not path independent, then the work done in a closed loop is nothing but df2 by dx minus df1 by dy dx dy calculated on the region that is created by the closed loop. Okay, but what is curl factor here? df2 by dx minus df1 by dy is the curl factor here. Because of this curl factor rotation tendency, we are calculating the net work along the line. We will see, since it is a curve, it will have a direction. If something is rotating, certainly it will have a direction. More on it, proving the Green's theorem and those things, that we will see. Please do support us. plus 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country code. We will see proof of Green's theorem.